and then when the weather changes like it has been here,
Mm-hmm.
I always lose my voice either in January or February. So, right.
Well,
So the
I
way
just wanted to say thank you for doing this. I know you're busy, and I really, really appreciate it.
I'm actually, this was actually perfect because my tutoring canceled today. So
Oh my
I was,
gosh, well, look at that.
just came home a little early and then you texted. So it's all good. So for
Oh,
these ones,
perfect.
what you're gonna do is plug in. You're plugging 9 plus h into the x wherever you see an x, right? So
Mm-hmm.
it's a square root of 9 plus h, and then it was minus 5 still, right? So that's that thing. To color coding here, plugging in 9 for everywhere you see x would give you this. Now you got to be careful and put parentheses around that. So it's
Mm-hmm.
the square root of 9 minus 5, like that. Okay.
Yeah.
All over h. So when you simplify this, this is just 3. So 3 minus 5 is a -2, right?
Mm-hmm.
And then -2 is a +2. And then -5 plus 2 is -3. So -3, and you've got the square root of 9 plus h minus 3 all over h. Now, you might think, well, that looks simplified to me. Well, it is simplified, but you can actually simplify it even more by multiplying the top and bottom by the what's called the conjugate of that top. And the conjugate is you just flip the sign. If it was a negative sign, you make it a positive sign. If it was a positive, you make it a negative.
Okay.
Okay. But you can't just multiply that on the top, obviously. You also have to multiply it on the bottom to keep the integrity of the problem. Okay.
Mm-hmm.
Now, why would you want to do that? You ask? Well, good question. What happens is when you multiply this together, you're going to get 9 plus h. The square root goes away, right? And then when you
Mm-hmm.
multiply this and this together, they go away as well. That and that go away. So you don't have that middle term. And then -3 times a +3 is a -9. And what do you know? What happens? What happens to the 9 and the -9?
Or I'm sorry, you asking what happens?
Yeah. What happens to this and this?
They cancel out.
That's right. And then you just have h over h, and h over h is cancels out to 1, right?
Mm-hmm.
So that's always what happens with this kind of formula. It always kind of works out for her. Maybe not always, but almost always it works out for you. This is basically the definition of the derivative.
Okay.
Part B
So
is
that is the derivative?
well, no, that's
Or I'm
not
sorry, the
this is
simplified quotient?
this is the derivative. The limit as h goes to 0 of that is the derivative.
Mm-hmm. So for part A, should I
Mhm.
always try to simplify it as much as I can before multiplying by the conjugate?
Yes.
Okay. I
Yep.
think that's what I've been messing up on is I don't simplify it first.
Yeah. Yeah. You definitely have to do that first.
Okay. And then when I FOIL it or multiply it all out, am I taking 9 plus h times it by 9 plus h and then, or I'm sorry, square root of 9 plus h times square root of 9 plus h, and then square root of 9 plus h times 3.
Yeah.
And
So
then,
yeah. So multiplying this out right here, if you didn't
mm-hmm,
catch that, when you multiply that out, this here will give you the 9 plus h, right?
yeah.
This will give you -3 times the square root of 9 plus h. This here will give you +3 times the
And
square root
then
of 9.
those cancel out.
Yeah, and that's always going to happen when you multiply by conjugate. That always happens.
Okay.
And then the
And then
last
it's
thing,
just,
yeah, -3 times +3 is -9. So
okay. That
You don't
makes
have to,
sense.
yeah, you don't have to bother. You don't have to really bother doing that. It goes back to this formula. A plus B times A minus B. Those are conjugates of each other. Equals
Hmm.
A squared minus B squared.
Okay.
So that's all you're doing is you're taking this and you're just saying, oh, look, that's my A is this and my B is this. And I'm going to
Hmm.
multiply it by its conjugate so that the middle thing, see what happens every time? The middle thing cancels out. And you don't have anything in the middle. You just have this squared minus this squared. So
Huh.
that's how you get rid of the square roots.
Okay. So that's
Okay.
why you multiply by the conjugate when you have a square root.
Yes, that's exactly why. Now for this, it might be different. This one, you're going to do something different to simplify this.
Hmm.
So for this, again, I'm plugging this in for my x. So f of that is going to be 1 over -1 plus h plus 4. I use parentheses when I plug it in, minus f of -1, which is 1 over -1 plus 4, because I plugged in -1, all over h. Now
Okay.
simplifying this, those parentheses are really not needed. None of these parentheses are really needed, but it's always good to plug it in just in case, because sometimes you can't tell. So this is 1 over h plus 3 minus 1 over 3 all over 1 over 8, or sorry, all over h, right? Now, to simplify this, it's a little bit different. For this one, you're going to want to multiply. This is what I call multiplying by the least common denominator. You're going to multiply the entire, or the top and the bottom, by 3 and h plus 3.
Okay.
3 h plus 3. There's a couple ways you can do this, but this is how I prefer to do it. And the reason you want to do that is because now when I distribute this here and here, it simplifies it, it cancels it out. And I will just end up getting 3 minus h plus 3. Got it?
On the top?
On the top. And on the bottom, I'm just going to have h times 3 times h plus 3. Okay.
Could you go over how you multiply the top by 3 times h plus 3?
How, or how I did that, or
Yeah, how
why,
you did that.
how I did it? Okay. So how I did it, I'll color code it. There's my blue.
Hmm.
That gives you this. This is my yellow. That gives you this.
Okay.
Think about what's going to happen when I multiply 3. When I multiply this up here by 3 and h plus 3,
Hmm.
what's going to cancel out?
The bottom,
The
like
3,
h
yeah,
plus 3?
the h plus 3, and what's going to be left?
Just
Just,
3?
just the 3. And when I multiply it here, what's going to cancel out? Between this and this, what's going to cancel out?
The 3?
The 3, and what's going to be left?
Just the h plus 3.
That's right.
Okay. That makes sense.
Okay.
Hmm.
Now I distribute the negative. So 3 minus h minus 3 all over 3h times h plus 3. So that simplifies, these 3's cancel into negative h over 3 times h plus 3. And the h's cancel. You getting this? Cancel,
Yes, I
cancel.
am.
So it's -1 over 3 times h plus 3. So that's your answer.
Okay. Yeah, I feel like my problem is the simplifying part or foiling it out. So either the simplifying in the beginning I struggle with or foiling it out is what I usually mess up on.
Uh-huh. Yep. Yeah. Calculus has a lot of algebra in it.
Hmm.
And you
And I've
need to,
never been good at algebra. So that's,
yeah. Yeah. That's why you do so many algebra based courses before you get to calculus,
Mhm.
because calculus is just full of it. Algebra is just a little part of calculus. Okay. The last page, page 4, show that it's continuous at 0 by evaluating. So to show that it's continuous, basically, this is just a quadratic. This is just a quadratic equation. Here, let's take a look at it on my calculator. Can you see my calculator?
Yes.
Okay. So if I type in this equation, negative 9x squared plus 7x, and I look at the graph, that's what that graph looks like, right? But it's only doing that when x is less than or equal to 0. So it's really only from here to the left, right?
Mhm.
Okay, so I'm just going to kind of rough sketch that over here.
Wait, but what about the right though? Because isn't it continuous on the right as well?
Well, hold on. That's only defined for x is less than or equal to 0. So it looks something like this, right?
Mhm.
That portion of that graph, if I'm using the red to graph that, so I'm using the red to graph that, that portion of the graph is going to look like that. But the portion to the right of it, so let's plug in that one now. This
so that's
equation,
only for the left side.
that's right. That's what a piecewise function is.
Okay.
It's defined in pieces. So if I graph that one, do you see what that does? It starts here and it goes like that. So that graph, which I'll do blue, this graph starts here and it goes down and then up like this. I didn't do that very good. Try it again. Goes down and up. Did you get that?
Yes, I do.
So that's what this function is. It's two quadratic functions that are pieced together at 0. So in order to prove that it's continuous, you basically have to show that the red and the blue one both end at the same place at 0. In other words, plug in, that's what they're telling you to do. They're saying show that f of x is continuous at 0 by evaluating, finding the value of f of x as x goes to 0. And then also by finding what f of 0 is. So the way to do that is, actually, I'm not sure the best way to do that. Well, how do they teach you to do that? How do they teach you to find the limit as x goes to 0?
They usually, hold on, let me look at this really fast and then I can tell you.
Yeah, so I'll tell you.
Exactly.
I'll tell you.
Okay.
What they want you to do is they want you to find the limit as x goes to 0 from the right and find the limit as x goes to 0 from the left. But I can't tell because when you click on this, it might do, I don't know why that has that box there.
Oh, that's if you want to add like a square root or like a it's just for operations.
So they're just asking you what is the limit. Okay. The limit x goes to 0. If I plug it in, basically I'm going to plug it into the left one, which is that red function. The one coming, I'm sorry, from the right is the blue function. The one coming from the right is the blue function. So that's 0. If I plug it in, look, if you plug 0 in here to the blue equation, you're going to get 0. And if you plug 0 into the red equation, that's coming, whoops, that was the one from the right, my bad. Start over. This one is the one from the right, and the limit is 0. If you plug it into the blue one, you get 0. And if you plug 0 into the red equation, you'll also get 0. And because of that, the limit of this is 0.
Okay. And does that mean, since both of the positive and the negative are 0, does that mean that it is continuous?
Yes.
Because they're both the same?
Well, they're telling you, they're basically saying.
Oh, they tell you that it is.
They're telling you that show that it's continuous by evaluating both of these. If the limit is the same as the function value, then it's continuous.
Okay, so
And
whenever
the
it says,
the limit, you have to use to find the limit, you show that it's the same from both directions. So you plugged it into both equations. So coming from the right, the limit is 0, and coming from the left, the limit is also 0.
mhm,
And the function value is also 0, because that one, see how the equal to is on the red one?
yeah,
So that would just be, you'd plug it into the red one, you get 0. So because of that,
oh, okay.
yeah.
So
And then it's
say,
yeah.
say that it's like the limit as x goes to like -2. Would you then plug in -2 to both of those equations and see if they're the same?
Um, mm,
No.
let me think about this. Ask me that one more time.
So say instead of saying the limit as x goes to 0, it's the
Uh-huh.
limit as x goes to -2. Would you then plug -2 into both of those equations and see what the answer is? Like, is that how you did
Yes.
this? You plugged x goes to 0, you then plug that 0, that number, into both of those equations and
Yeah.
solved
Well,
it?
that would also mean that this would have to be, this one right here would have to say -2 and -2.
-2.
Yeah.
Okay. But basically, you plug that number back into
Yes,
the
correct.
x, whatever number. Okay, that makes sense. Thank
Yep.
you.
So about the part B says evaluate the one-sided limit. So now you're doing that formula thing, right? And this is where it
Hmm.
gets a little. So for the one side, the limit as it goes to the left, that's the red one. So you're plugging in, or as x goes to 0 from the left, I should say. So you're plugging this thing in just like we did on the last page. You're going to plug
Hmm.
this in into the equation, and then you're going to simplify it. So
Okay,
that's,
so it's pretty much what we just did
yeah, but there's a lot of work there,
because
right?
it's 9x squared plus 7x.
Yeah, because you're going to have to plug in. So we're going to have to plug in. I'll just do it real quick, but I'm not going to color code it because it'll be too hard. I'm plugging into the red one. So it's -9 x squared plus 7x minus f of 0 would just be 0, right? Because when you plug in
Hmm.
0, 0. But I would have to plug in 0 plus h and 0 plus h. Unfortunately, 0 plus h is just h, right?
Hmm.
So that's just -9h squared plus 7h. Make sense?
Yes.
That's on the top, and what's on the bottom?
H.
So I can factor an h out of the top, right? And
Hmm.
I'll have -9h plus 7 left over, and I'll have h on the bottom. Cancel those out. Got it?
Yes.
And that means my answer is -9h plus 7. But now it asks me what's the limit as h goes to 0 of that. The limit as h goes to 0, plug in 0 for h, and you just get 7.
Okay.
So your
Okay.
answer
So then
7.
after you do that, you have to plug that 0 back into the equation that you just solved for to get 7.
That's this problem right here.
Okay.
Now, if I did that same thing for the blue one, I would say the same thing, but now I'm using the blue equation. So 5 times x squared minus 5 times x, right? Minus, that's this one, minus f of 0. And what's f of 0 again?
0.
In this case, it's 0 all over h. And what am I plugging in? I'm plugging in 0 plus h, which is just h, right?
Hmm.
So what do I get? 5h squared minus 5h all over h. Factor out an h. You get 5h minus 5 all over h. The h's cancel. You just get 5h minus 5. And what's the limit as x goes to that? What's the
You
limit
plug,
as h goes to 0? I'm sorry. What's the limit? The limit as h goes to 0 of that is what?
would that just be 0?
No, plug in
Oh,
0.
no. It would be
It'd be negative
negative
5.
5.
Yeah. So that's that one.
Okay.
Now, the whole idea behind that, what they just showed you,
Mm-hmm.
look at our graphs again. Have you learned yet that about tangent lines?
Yes.
Okay, so the derivative is the slope of the tangent line, right?
Mm-hmm.
So even though this is a continuous, even though this function is a continuous function, it's not differentiable at 0 because the derivative from the left is different than the derivative from the right. So let me explain why that is the case or how that happened. Look at that blue line. Here's the blue line right here. I'm tracing the blue one. Okay.
Mm-hmm.
If that were to continue, it would be going up like this, right?
Yeah.
And what would the tangent line look like at that point? What would that tangent line look like?
Would it be going up towards the point?
Yeah, it would be going this way. Here, your tangent line would be looking like this. Right?
Mm-hmm.
And the slope of that tangent line, guess what it is?
7.
It's negative 5.
Oh, negative 5. Sorry.
Right? That's the blue one. See how the slope's going down from left to right?
Mm-hmm.
The slope of that is negative 5. Whereas this one right here, if I was going this way, remember how it went through and then came down like that?
Mm-hmm.
Remember that? But
Yeah.
we cut it off right here. Well, if I put a tangent line here, what does the slope of that one look like?
That one is 7, right?
That's right. That slope is a positive slope. In fact, it's 7 because it's this slope right here.
Okay.
So that point is continuous, or this function is continuous. This piecewise function is continuous, but it's not differentiable everywhere, meaning you can't take the derivative because at 0, where it kind of came together, it might be continuous there because it's the same point, but the slopes are different coming from the left and coming from the right.
So you said because they're different, you can't take the what?
The derivative.
The derivative. And so if
not differentiable. So part C says use part B to help you evaluate f prime of 0. And the answer is does not exist.
Because they aren't the same number. But if they were like both 7, if both of those equations were 7.
That's right. Then it would exist.
Okay. That makes sense. Mm-hmm.
Okay. Sound good?
Yeah. Yes, this is perfect. Thank you so much.
Yeah, no problem. That all you had?
Yeah, that's all I had questions on. But seriously, thank you so much. This is very nice of you to help me.
No problem. I'm happy to do it for you.
Thank you. And then where can I find the video?
It's gonna be, hold on a second. Let me get to my Zoom so I can turn it off first.